32. Ultrasound is a medical technique that transmits sound waves through soft tissue in the human body. Ultrasound waves can break kidney stones into tiny fragments, making it easier for them to be excreted without pain. The shattering of kidney stones with specific frequencies of sound waves is an application of which wave phenomenon? Alright, so what's happening is they're putting these ultrasound waves into the body, and somehow it's breaking the kidney stones into tiny fragments. So how is it doing that? Well, the Doppler effect describes this situation where you have a source that's moving, and because the source is moving, or the receiver, the person that's receiving the source, is moving relative to the source, then the frequency that's perceived is different than the actual frequency generated at the source. That's not really what's going on here. It's not really anything to do with a change in frequency. They're only putting in ultrasound waves at one frequency, and it happens to be just the right frequency that it's going to break the kidney stones. So it's not the Doppler effect. It's not reflection. Reflection is the idea that you have an incident wave striking a reflective surface, and then the angle that it hits that surface with is going to be equal to the angle that it leaves the surface with once reflected. That's not really what's going on here either. Refraction is the idea that it's actually similar to this. Instead of it being reflected, it actually travels into the new medium, but it bends toward the normal. So it might look like this on the other side. And then we can do some calculations around what the angle will be after it passes through. Again, that's not what's at work here with breaking the kidney stones. What's happening here is referred to as resonance. It's this idea that the frequency of the source, the ultrasound waves that they're putting into the body, is at just the right frequency that it creates standing waves inside or at the kidney stones. So the classic example of this is the opera singer and the wine glass, right? The idea being, when she hits that super high frequency, it's just the right frequency, however many hertz it is, that those waves come out, they go over to the wine glass, and they create standing waves in the wine glass at its own natural resonance frequency. And as a result, it can cause those waves to amplify. It can actually break the material, and then the glass shatters into a million pieces. The same thing happened with a very famous bridge, Tacoma Narrows Bridge, where it vibrated at its natural frequency due to wind patterns that started the process, and then because of resonance, the amplitudes increased, and there's actually videos you can watch on YouTube. The bridge just collapses because those frequencies become amplified so much. But it's the same principle here. They're using these ultrasound waves, probably a much higher frequency, but they're doing it at the resonance frequency of the kidney stones, and they're actually able to break that material down.